Quand je commençais à l'écrire, c'est comme ça que je l'écris. So we are going to start the meeting in a minute. Please go to your chairs. People at the end of the room, please close the door. For your own security and safety, please close the door. Okay, so this is the Lpwan working group. We have Dominique Bartel here acting as chair. Alex is not with us. He's the proud father of a young Leonard. So we welcome Leonard to this group. And so hello to Alex, who will be joining us from ETCO, but it was much easier that just Dominique would stand with me at the chair. So with this, we're staying. As usual, we won't distribute the blue sheets immediately. We'll wait like 10 to 15 minutes for the usual late people. So this is an IETF official meeting. All the best practices of IETF meetings apply, in particular the rules about patents, if you're aware of any IPR that applies to the discussion that takes place in this room, whether it's from your sponsors or whoever, please let us know or refrain from talking about this. And if you don't want to speak during the meeting, you may always talk to the chairs after the meeting. The other best practices also apply, anti-harassment and all the others, so they are listed on this page. The meeting is being filmed and recorded, and actually it will be published on YouTube, I'm sorry. And actually what's very cool is you can extract the transcripts from the YouTube page. So I'm sure you can make a rule that translates Yahoo into YouTube and fix me. So so everything is recorded, minutes are being taken, blue sheets will be distributed. I want to make sure that we have people joining the Etherpad. That's the mean we use to take minutes. What's very cool is you can join it online. And if you speak to the mic, please check after that what you said was captured correctly. Make sure that your name was captured correctly, so we publish accurate minutes. Okay, so please all join the Etherpad and review the minutes as they're being taken, mostly if you've been speaking. So who can take minutes? Okay, we have 2, 3 minutes. Is there somebody on the Jabber? Ivanio. Yes. Okay, thank you, Ivo. Okay, and then all the material is available on this page. It's also available from the agenda page on the IETF site, and that's actually what we use to go from presentation to presentation. So we have a lot on our plate today, but we have 2 hours, so I'm kind of confident that we won't have any problems, so I won't be pressing people, I don't think so. The new thing compared to the agenda that we had published until the bar date is that we have an interesting presentation on a Chile implementation coming from Chile. So this one will be actually appended to the presentation by Dominique. So in those 15 minutes, I guess Dominique will speak for like 10 minutes, and then we will be able to discuss, I don't know how you pronounce it, psychic? I don't know. the Paishik. So we'll be able to discuss that as well. You will have some time. Then Sigfox, LoRaWAN. So this time there was a lot of work done on the LoRaWAN specification, many discussions on the mailing list. So we gave more time to Ivo so he can actually tell us the best and latest about how the LoRaWAN profiles shake. Then the data model. And actually, I just got a text from Suresh. He said, I won't be joining the meeting immediately. Start without me. He said, yes. If Suresh is not there at the time of the young thing, I would like to push it till he arrives. But I guess he will be there because it's now an hour from now. Then the co-op static context, OEM. So Dominic will step to discuss OEM again. And Carles will show us the progress on the RTO discussion. Charlie was supposed to give us an IEEE status. As it goes, Charlie did not join the Mythico, so I don't know if he will be with us. If Charlie, you could join, let us know. Do you see Charlie on the Mythico? I don't. So I'm not too sure that we will have Charlie this time, but okay, we'll get the news next time. And then we'll discuss rechartering, because we are pretty, I mean, the basic, oh, sorry, sure, here. So the barring thing for rechartering was complete SHIC. So SHIC is now passed, so we can really actively work on the recharter now. And that's it. So as I just said, our main work item is now complete. That's the baseline SHIC technology, and that was the main effort in this group. We plan to submit the co-op compression to ASG in November. Laurent, are we still in line with this goal? I think we are from the last intro. From my side, yes. From your perspective, it's okay. So we'll have a discussion at the end about rechartering, Suresh. That's pretty much it for the intro. Any bashing? Okay.
Tu me dis une bouton que j'ai un peu prémonté.
10.
Enfin, tu me dis 5 et 10. Hello, good morning. So this is a status about the basic SHIC draft, IPv6 static context. We're currently in version 21. So I'll spend just 1 minute or two remembering people what this draft is about. So if you're new to the working group, if you haven't looked at that before, here's your chance to understand what this is about. And then I'll go over what we've done since last IETF meeting, a little report on the hackathon we had the weekend just before this week, and what's coming up after this. And in the back of the slides have the list of changes. If there's any question on what exactly we did, we can go over that, but otherwise I'll just skip it. And then okay. So what is draft about? I like to say there are 3 deliverables in one draft. One deliverable is a generic header compression mechanism that uses a static context. This gives the name SHIC to the whole technology, static context header compression. So it's that part in blue in my protocol stack here. And I've shown IPv6 UDP, but actually nothing in this header compression mechanism is dedicated to these upper protocols, so we can apply it to anything that's regular, has things that look like headers. In the same draft, we also have the specification of a fragmentation protocol, and we have 3 versions of fragmentation, 3 modes, which address different underlying network requirements. These are the 3 boxes I've described here, and it's kind of compression over fragmentation. It's not really encapsulated. That gets people a little bit confused sometimes. We need to be better at explaining. And in the same draft, we have a simple example, I would say, of how we can apply compression to IPv6 UDP. It's simple because we don't consider IPv6 versions, options, sorry. And so all the fields happen only once, and they are fixed in position, fixed in length, so it's pretty simple. And the more complex stuff comes with co-op. So this is a red box here. So you will find these 3 things in the same draft. And so other drafts do the rest of the stuff, like this red box shows the co-op draft. So applies header compression to all this upper protocol stack. And the other drafts, like SHIC over Sigfox, SHIC over LoRa, that we'll hear about today, do these red boxes. How do we apply mostly fragmentation over various technologies because they have their own specificities, and so they pick 1 or 2 or 3 of the fragmentation modes and set parameters so that it fits the characteristics of the underlying technology. So that's my view of the whole work we're doing in this working group. Yeah, and so far the draft I'm talking about has specified the format of frames that go over the air, or that we pass on to the underlying layer. But so far we haven't defined how we express, how we represent the rules that are used for compression and fragmentation. So part of the other drafts propose a representation of the context, the rules, the parameters for fragmentation and everything. So this is not in this draft. Okay, what has happened since the last meeting? So fairly long list of technical stuff, but we had IoT idea review by Carsten, which was only part of the document. We discussed with Carsten at Prague and agreed on most of the changes. We improved the description of Icon error mode. There was mistakes in the description. We received an AD review by Suresh, etc. Completed IETF last call. I haven't heard of any comment, so far looks good. And we published 20 and 21 in the last few days. So the current status is waiting for write-up, and you can probably say more.
Yeah, Suresh Krishnan. So it's like a procedural step for me to issue a ballot, so it gets on the next available telechat. So that's so you don't have to worry about it. So I just wanted to know if there's any other edits you queued up. There's nothing.
As of today, nothing.
There's nothing, right? So I'll issue the ballot because what has happened a couple of times now is I issue the ballot and the author updates the draft after saying, hey, I got this review and I'm fixing it, right? And then some of the IESG read an older version and some of them read the newer version. And that kind of I wanted to avoid that. And anyway, it's IETF week. Usually you don't do anything because nobody's going to start working on it. So this afternoon I'll issue the ballot and it'll get on next, depending on number of pages. So previously you would place stuff explicitly on a telechat, but now it's automatic. So it looks at the reading load and then puts it on the telechat. So I'm expecting the 22nd of August, it'll be on a telechat. Okay. So it gives people time to read the stuff, all the directorate reviews and everything and so on, whatever is left over. Because some of the directorates do last call and telechat reviews separately. So Genart, for example, does it separately. So they do a last call review and look at the updates and do a telechat review after. Okay. So I don't expect anything to come out of it, but they do want the time to do that. So they kind of expect a 2-week window. So that's why I'm saying 22nd would be a good date. So, and if you want, Pascal, Dominique, Laurent, if you want to be on the call, you can be on the call. You cannot speak unless, I kind of ask you to, but you can be on the call. Anybody can be an observer on the call. But I could say, hey, if I have some questions for you, you can actually answer it. So it gets done quicker rather than wait another 2 weeks. Okay?
Yeah, if possible, I'd like to be on the call because I've never.
I'll send you the WebEx information to you, to all the authors and the chairs, so you can decide if you want to join. So it's 4 p.m. In France, Thursday.
Okay.
Always. Yeah.
Thank you.
Thank you, Suresh.
Just a quick report on the hackathon. So there were 10 team members over the weekend here. 7 here and 3 remote from Chile, Spain, and Japan. So actually, it was Soichi worked overnight for us, and when we came back in the morning, he had done quite a lot of work over our night. So that was really great. And so we basically worked on 2 fronts. One is make OpenShift easier to use. So producing documentation, cleaning up, adding a tutorial, how you get the thing started, and also improve the functionalities of the code. Quite a lot of work merging several branches that kind of diverge between meetings. And so we now have a compression and fragmentation integrated into the same branch, same code, which wasn't the case before. And I'll talk about OAM later. Coming up next, well, I think Suraj described what is going to come in terms of the draft itself, and we want to communicate more about SHIC, educate people about SHIC. We get lots of questions. I don't quite understand how this works, etc. So we kind of agreed we'll prepare a full-blown tutorial on SHIC that we can play to the LoRa Alliance or other groups that are interested. Carry on with OpenSHIC, of course, and I know there's academic work to evaluate performance and applicability. This is kind of outside the draft itself, but just to communicate with you the kind of interest we get about SHIC. So, of course, there are other drafts of this same working group that use SHIC, obviously, but there are demos happening. Co-op UDP IPv6 compression over LoRaWAN, over Sigfox, already a couple of years ago. Co-op compression over LTE-M, so we're not compressing UDP IPv6, but just a co-op part of an IP-enabled network and still getting benefit of the compression. So just again to mention that co-op is not, SHIC is not dedicated to the IP layer, to sit below the IP layer. It can sit at any point in the stack. SSH over LoRaWAN. And SHIC is being evaluated at the LoRa Alliance for the DLMS transmission over LoRaWAN. So they have DLMS over UDP IPv6. And so we have UDP IPv6 over LoRaWAN. So that could solve their problem. Daniel here is interested in using SHIC for IPsec ESP compression. And in terms of implementation, we have OpenSHIC, which I already mentioned. We have Aclio. They have commercial code, both in C and Go language, both for the device and the network server, commercial grade, operational. And I just heard last week about the new implementation, so Sandra is going to tell us a little bit about this just after my presentation. And Riot have expressed interest. They are not currently actively working on it, but they have intention of implementing OpenSHIC in Riot, either by rewriting a C implementation, which would be therefore a different implementation, or by running MicroPython over Riot and then reusing some of the OpenSHIC code. Okay, well, do you want me to go over the changes? Do you have any specific question? Oh, no, it's there for reference. So I guess, Sandra, you can tell us about your implementation.
Any question?
Forward, backwards, next.
Okay, hello everyone. So I'm Sandra Céspedes from Universidad de Chile, and I will present a work from, actually this is a work from Rodrigo. He's a master's student, and this year we started implementing the draft for SHIC over LoRaWAN. So I'll just give a brief report of what is the status of this implementation. So basically, this is the architecture that we are using. This is an experimental setting. So we have a low-pi end device, which is connected to a rack wireless gateway. And then this connects to the Things network. And the other part of SHIC is implemented in Amazon Web Services. So he's using an API gateway, talking via REST to the network server. And the actual implementation of SHIC is in Lambda function inside the AWS services. So this is the status of the implementation. What you see here on the right is the modules that are part of the implementation. So basically, we have a big module with compression, decompression, and the other module is for fragmentation and reassembly. The one that is almost ready is the first part, the compression, decompression. This has a compressor, which gives the output is the SHIC packet. And then the decompressor, which receives the SHIC packet, and the output is an IPv6 plus the UDP packet. And then there is a parser that gives us access to all the headers in a SHIC packet. And the rule manager, which is the one that loads the specific rule that we need to apply for a compression action. So all the rules are implemented outside in a dictionary, and then the rule manager just loads the specific rule that we need to apply for a compression. And then, so this is around 90% ready. The fragmentation and reassembly module, this is in charge of another student, so I will see his work next week, and then I can tell you if this is also working or not. I couldn't say yet if it's working. I already said this, so far we have tested the uplink for the compression, and it's working. We haven't yet tested the downlink, but the code is there, it's ready, we just need to do the testing. And also for the fragmentation, we haven't done any testing yet. What we have pending still, so this 90% comes from the fact that we haven't yet implemented these two compression-to-compression actions, which is mapping set and LSD, basically because, so Rodrigo said he's connected, actually. He said that he wasn't using them, so he just skipped the implementation for now. And then, as I said, we need to test the downlink for the compression, and we want to do an end-to-end testing with all the IP connectivity end-to-end. So this is going to be the last part to test. So we plan to do it first only for the compression, and then when we have the fragmentation code, we do the complete thing. And I was going to say something else, but I forgot. So I think that's about it.
Laurent Toutain, so thank you for this implementation. It's very interesting to have plenty implementation. So maybe we can try to make some interrupt in
as soon as you give us rules, right? The format for rules.
And do you implement co-op?
No, not yet. Just UDP. Okay. Yeah, it's just UDP. And also we plan to make the code public. So it's not there yet. We haven't documented the code yet, but it's going to be available. So we will tell the group when the code is ready to access.
If I will be sure. So I understand that your fragmentation is 50% ready, but did you look at the LoRaWAN, SHIC over LoRaWAN draft, or only on the base draft?
Both, yes, both of them. So what I understand is that Rodrigo, whatever he couldn't find in one, he just went to the general one and then implemented what the general one said. Yeah. That's it. Okay, thank you.
Thank you very much. We're very interested in your feedback. If you saw anything missing, trying to do this coalescence of the LoRaWAN and then the main draft. If there was any
we started
question,
doing that. Yeah, he emailed a couple of times, and then we'll keep doing it if we find something.
Yes.
In the draft. Okay.
Thank you very much.
And I understand you will be at the next meeting in Singapore, right? No, I mean you or Rodrigo. Your hackathon, yeah. So maybe we can plan for interrupt. Let's work on that.
Yes, I hope it's very clear to everyone in the room that what's really critical now is to get a common format for the rules, so we can feed the rules into both implementations and try one implementation on one side and the other implementation on the other side, right? Right now it's kind of blocking us for interrupt because we can't express the rules in the fashion that both codes can digest. So that's really the next important step for us.
Good morning, everyone. Juan Carlos Zúñiga from Sigfox. So I'm going to talk about the draft IETF LP1 SHIC over Sigfox. Just a quick note to welcome the new member in the group, because Alex is not here. And I think I saw Alex in the note there. So congratulations, Alex, on the arrival of the new member. Yes. So yeah, very quick update. There is we have done modifications to the draft. What we've been doing is working on optimization of the SHIC parameters for payload fragmentation and data integrity over Sigfox. As a reminder, Sigfox has fixed size for the payload. So in the uplink is 12 bytes and the downlink is 8. So basically we can optimize for that one single frame size that is not changing, and that's the idea to make sure that we get to the best possible numbers for the different applications that we foresee to use this data integrity and fragmentation. So we have two basic scenarios. The first one is a single byte header that is right now optimized for minimum overhead in providing an ACK size of 13 bits in the downlink. And the other one is a 2-byte SHIC uplink header that is optimized for maximum payload with an ACK size of 43 bits in the downlink. So this is more or less what the simulations look like. If we want to push the limits, with a single byte header, we can go all the way to roughly 300 bytes, a little bit over that, but 300 bytes comfortably. And this is using the ACK and error mode. So the idea, the idea is to support this payload with as little as a single byte and 13 bytes ACK needed, meaning that in the best case scenario, if there are no fragment losses, of course, we will use a single downlink message to support all those messages sent in the uplink to support 300 bytes. For a 2-byte SHIC uplink header, again on the ACK on error mode, we can support all the way to 2,000 bytes. Not necessarily that it's recommended, but that's what it would work. Then again, as little as one single ACK would be needed to support all that payload. And in this case, it'll be a 43-bit ACK that fits perfectly fine in the Sigfox downlink. So we plan to keep working on this, and of course, bring it to implementation to try to test the limits of the protocol and see how we can. Sorry. We can further optimize the protocol. So that's it. Any questions? Okay. So thank you very much.
Thank you, Juan Carlos. And the next presentation will be.
You're taken care of. We need you.
À gauche, c'est à ma gauche. Si tu veux bien, Laura Wan. Il va où, Guillaume? So you have 25 minutes.
Okay. So hello everyone, my name is Ivo Petrov and I will be presenting the advancement of the Shikova LoRaWAN draft. So I will start by giving you a little bit of context about LoRaWAN, then I will present you the changes that happened since the last IETF, and then I will tell you what was some of the rationale for the changes that we did, and we can have a discussion if you have any ideas or any comments. So in LoRa, there are three types of devices, three classes. Those are class A, B, and C. Class A are the most constrained ones that can receive downlinks only after sending an uplink. Class B have some time slots at which they can receive downlinks, and class C could receive downlinks at any time. Obviously, this is important in terms of how the fragmentation is specified, because some timers might differ between the different classes. Then there are confirmed and unconfirmed messages that I will also tell you a little bit more about what is our opinion a little bit later. And another particularity of LoRaWAN is that there are multiple implementations of network servers and device stacks, which means that there might be some differences in implementations that do not allow to use some of the nice properties of the underlying layer. And so there are parts in the MAC layer headers that could vary in size or that could be useful for us to use, namely fopt and fport, which I will show you in a second how they are structured. And the last particularity that I want to mention right now is that due to some differences in regulations in different countries, the maximum size of packets is quite different between optimal radio conditions and suboptimal radio conditions in some parts of the world. So this is also something we have been taking into consideration when providing the parameters for the LoRaWAN for the SHIC fragmentation. So as you can see in this picture, we have different headers in the LoRaWAN packets, and some of them, namely the fopts, used for optimization of radio of the radio links and some other things that are below IP, but they can vary in size, which could make a little bit harder the selection of most optimal parameters for all types of payloads sizes. And then there is the fport that I mentioned earlier, which is mostly for applications to specify what is the payload about, and I will explain you how we use it in order to communicate information related to SHIC or YD. So, since the last IETF in Prague, our document was adopted by the working group, and it was in version 3. Now we have published 2 new versions, and we received some very useful feedback. So thank you everyone that gave us some ideas, some recommendations. So here are the changes that went in the document since the version that was accepted by the working group. Sorry. Yeah, I think there's something in the air here. I have been talking about some of them at the last IETF, but they were not part of the draft, so some of them still changed, so I will present them again here. So we updated the information, we got in sync with the base document. Thank you. So, yeah. Sorry. So we got in sync with the base document and updated some of the terminology and some of the figures to match the base document. We decided to switch to Acon error for uplink fragmentation, as we believe it will be more optimal for those cases. For the downlink fragmentation, we decided to keep the ACOIS mode, as Class A devices will need to be sending uplinks in order to be able to receive the downlinks anyway. So we provided some more details how LoRaWAN terminology maps to IETF terminology, so that people from both SDOs can read the draft easily without having to keep too much information in their heads. And we decided to replace the quite generic term devices, which seem to be confusing for some readers, with the more precise one, and devices, where it was appropriate. So we then decided to split the F port up that we were using for uplink fragmentation into two, so that we have one which is more optimal for smaller packets and one that can handle the requirements of IPv6 packets. Yes, Julian?
Yeah, Julien from Kerlink. So are those two ports dedicated to fragmentation, or are they used also for compression?
And those, well, one of the F port has the possibility to be used also for compression, whereas this is the F port up default, and the F port up short is only for fragmentation. Basically, in F port up short, you don't have any space for additional row IDs, so you have effectively only one row ID. And in the case for F port up default, you have space for other row IDs, so one of them is for fragmentation, and the rest of them are for compression.
So my opinion is that it's very confusing that having the same F port for compression and fragmentation for the F port up default. So I would advise that we select F port for fragmentation only, maybe several if we need optimization, and having a dedicated compression F ports if needed. The rationale behind that is that the rule ID and the rest of the payload below, after that, is different in fragmentation and in compression. So actually having several rule ID for F port up default has no use in fragmentation itself, and it's consuming a lot of bits in my opinion.
Okay, that's interesting. We can consider it. Yes, Dominic?
David Bartel, as an individual. I think the way it's described currently, I think it's confusing. It's being this use of F ports and roll numbers. It's basically the way, and I've had this discussion on the mailing list, this is not new. The way it's currently described, it looks like you have actually 3 instances of shape or of the context separately, and F port selects one of the instances. For example, the F port up short designates one context which has only one rule, therefore you need 0 bits to identify the rule ID. And then the F port up default has an 8-bit space for rule ID. So either I mean, there's nothing wrong with that, but then you should, I believe, describe it this way. We have 3 contexts that are selected by F port, or the way I propose on mailing list, you describe rule IDs to include this F port byte. And so you say we use rule ID numbers that have at least 8 bits, which overlap with this F port of LoRaWAN, and maybe have some other bits, so variable length encoding. And the F port up short uses only 8-bit and with a known pattern, which is this value of F port. So in the vision of SHIC, this means you have only one context with rules of variable ID length. So either one or the other. Obviously, at the end, it's exactly the same thing. Yes. You get the same compression, same frames out of the stuff, but the description would be clearer. So pick one of the two, but it should be clearer, I think.
Okay. Did you actually propose text, Dominique?
Yes, I did.
Okay.
On the mailing list. But I'm going to work with Olivier probably on Monday, again, try to make my point.
Okay, yeah, thank you.
From Java, Rodrigo Munoz is pointing out that on some platforms you cannot access the F port. So, for example, in PyCon.
Okay.
But Olivier is answering that it's possible there.
So Olivier can come to the mic, so I will just...
Hello?
Olivier, yep.
Yeah, perfect. Yeah, Rodrigo, you can access the FPort on the PyCom. I think it's the LoRaWAN structure.socket or something like that. I can't find the documentation if you want. If it's a LoRaWAN certified device, you should be able to access FPort because it's a part of the LoRaWAN specification.
Thank you, Olivier.
Yeah, so Rodrigo, if you have questions, you can find the email of Olivier and ask him. He will be glad to help you, I'm sure of it. Okay, so I carry on. So we have selected tile size of 3 bytes. And in order to be able to optimize for the different radio conditions, as I said earlier, in some regions, the maximum packet size is 11 bytes. And in case there is some f-ops that are present, this might be reduced even further. That's why we decided to keep some flexibility there. And yes, we updated the terminology to match that of the Dash 18 version of the sheet draft and added extra examples. Yes, Lacan?
Yes, just one precision. The size of 3 bytes is just for the F-up short, or is for every fragmentation?
It's for every fragmentation. And yes, we received some feedback from the chairs that we need to reorganize the author list, so we did that. And yeah, we handled some minor other comments from the working group as well. So yes, and here is an example of the payload format. So we have at the upper side of the slide the regular packet for the short version, and which doesn't have row ID and window number. And we have in the down part of the slide the fragmentation where we have those 2 additional fields. So one is for F-port short and the other for the F-port up default. In the short version, we have DTAG, F-count, and then the payload, and we only use 1 byte for the additional header. Yes.
So Julian again from Kerling. I have more questions for the SHIC authors. DTAG 1 bit, is it really useful in such case, or is it something we can skip? I was wondering if on LoRaWAN case the DTAG being 1 bit is useful or not.
DTAG has 2 functions. The first one is to...
Please state your name.
Laurent Toutin, IMT Atlantic. So DTAG has 2 functions. The first one is to merge different fragments together, but it's also when you finished your transmission, you have to delay and wait if you lost the lax acknowledgement. So you must keep your context for a certain period of time. So using the DTAG, it allows you to send another fragment and don't wait for this period of time.
Okay, Julien again from Kerling. So this means that you can mix up 2 sessions or 2 uplinks with the DTAG with 1 bit? Okay, because I believe we said in the beginning of the draft for LoRaWAN that we do not interleave fragments.
Yes, that's correct.
Yeah, Dominique. So yeah, I was surprised to see this DTAG bit here, even though you said you don't interleave fragments. So you could do without. And I think you added it just for extra safety, but I don't think it's mandatory.
Okay. Yeah, I
Olivier is on
think
the-
it's for extra safety. Yeah. Maybe Olivier will want to add also something.
Yes, Olivier.
Do you hear me? I have connection issues.
Oh, very well.
Yeah, perfect. So we added detect just in case of error recovery because it's faster to detect an issue when the detect change. But we specify that we don't want to use and to mix 2 sessions at one time because we are in embedded context with a lot of constraints. So it will reduce program size and all memory and RAM needed in microcontrollers and simplify implementations.
All good.
But it was when we thought that it was better to have byte-aligned headers. It was a mistake, so it can be discussed, and we are open for all feedback on that.
I figure that if you have all sorts of timeouts and race conditions, that avoids race conditions with timeouts happening somewhere. I guess it's a good idea. Thank you, Olivier.
Okay. So yes, and here you can also see the format of the acknowledgement. I hope that doesn't come as any surprise for people that know the original SHIC draft. So yeah, we have the DTAG, the CBit, the encoded bitmap in case of an error. I mean, missing fragment, and then padding as needed. So carrying on, for the version 2, we mostly did some very small changes, fixed some figures, updated the reference to -19, and made sure that we are in sync with this version of the draft, and fixed some examples and added some more.
So Julien Catalano again from Kerling. I have another question for examples. I saw that there are not byte aligned in the SHIC compressions. I'm a bit afraid of the implementation issues it can bring. So the compression residue is not byte aligned, and the payload comes right after. So I guess this is a decision you make here, but could you give some more rationale?
So the decision for the residues themselves to be bits is for compression efficiency. So if there's only 1 bit of entropy in some field, then we only send 1 bit on the wire. And then the question was, do we pad to a byte alignment after the residues, before the payload? But then I think the reason was that we would get 2 paddings and in case of fragmentation. And so we decided we'd pad only once. And that's why we stuck the payload right after the residues. And we work under the assumption that shifting is no cost. It's 1 CPU cycle. And so extracting the bytes with shift doesn't cost compared to sending a bit on the link. So more computation power than transmission opportunities.
And there are long threads on the mailing list on that, so you can dig more and come back to us and ask questions.
Okay, thank you. Just for to make a point, shifting is quite easy, but shifting 38 bytes, like in the example we have, might be complex for the implementers. But okay, yeah, fine. Double padding is the rationale. Thank you.
Thank you. So yes, now things that have been discussed as possible upcoming changes is to remove the restriction of the row ID size. Basically, right now we are saying we recommend people to use the two F ports and have row size of 6 bits, but in some applications that might be insufficient. In others, it might be more than enough. So the comments that we received was to try to reorganize the draft so that we don't have these restrictions. And this is something we intend to do, have some specified row IDs that are recommended for fragmentation. Maybe still keep 2 of them. That is something we'll have to decide. I think we'll keep 2 of them. But in any case, the applications should, implementers should have the flexibility to decide what is the optimum row ID size for them. And there have been some small typos and some small details that were missing in the draft and that were maybe confusing a little bit implementers. So we will be fixing those. So now about some more technical details. In LoRa there is a bit which is called fpending, which can tell an end device that the network has some more data to send to it. In the draft, we explicitly state that we don't want to rely on this thing because it is not handled very well by some of the implementations, so it might cause some issues. And similarly for confirmed versus unconfirmed messages, it is possible for some stacks to send a confirmation before the SHIC and the SHIC layer can actually add any extra payload, and the confirmation could very well be piggybacked with the SHIC payload, so it didn't make too much sense to use confirmed messages in this regard. We might be sending more messages than needed. So now a little bit more details why we decided to use tile size of 3 bytes. After some consideration and running some experiments, we found that this seems to be the optimal tile size if we want to be able to both from time to time send some MAC commands using the fopt header in LoRaWAN, and at the same time be able to say to send big payloads without using too much size in the bitmaps. The bigger tiles improve the bitmap size, but at the same time, as I said, we have less flexibility. So what is remaining right now is to finalize the IID computation. There is some text already regarding this thing, but I believe it needs to still be improved. And I think that this is the only pending thing to do, except, if we receive any more reviews, we'll be more than happy to discuss if there are other things to change, but this is the only thing that I'm aware of.
I have one more thing I would like to ask the SHIC others about the message integrity code, so the CRC32. Can we use another algorithm? In LoRaWAN, we do not have this CRC for standard implementation, but we do have the message integrity codes, which are based on AES CMAC. Is it foreseeable to use that?
Okay, Dominique. So your question could be twofold. Are you talking about removing the check at fragmentation, or implementing another computation for the check?
Maybe implementing one other.
Okay, so it's totally possible. The draft says CRC32 with this default polynomial is a recommended algorithm, but you can implement your own as long as you feel it's robust enough for the purpose. So that's fine.
Thank you. So we would like to get some more reviews, of course. More reviews are always welcome. And we believe that we should be ready for last call before the next IETF. What is the chair's view on the process?
I mean, if there are no remaining questions and the document is stable, the chairs are more than happy to go for workgroup last call. So I've seen just one issue that needs to be resolved is this longer normal F-ports in discussion, the format. That's the only discussion I've seen. Mm-hmm. So once you complete that, yes, we would like to have 1 or 2 reviews from the room, just to make sure, that some things are coded before our group last call. So are there 2 people in this room who could volunteer to review the document? Georgios? And even 1 more hand? Yeah. Dominique? Okay, so please sort out the issue of Dominique. And then I will ask Georgios, and Dominique is already on it anyway.
Then I'm biased.
Yeah, but for that one issue, yeah, but there's all the rest of the documents. So please, and then yes, we will do the last call. I mean, what's holding us?
Okay, perfect.
Somebody on the Jabber?
Yes, there's a question from Sergio Aquilar. Is it possible to have a variable tile size depending on the MTU?
Why is it only 3?
Yeah.
Why did you pick only 3 bytes for the tile, or could you make it variable?
By definition, this is Dominic. By definition, the tile size is the fixed value that fits all MTUs. That's how the system was built. So now, if you're saying you want a variable minimum size, then it's kind of meta redesigning the protocol. So no, the tile size is really this minimum constant, and then otherwise the Acorner doesn't work. Are we talking about Acorner, by the way, Sergio?
And yes. Olivier will be at the link as well. We'll see you, Olivier.
Okay, so in Acorner, you need to be able to resend data that was lost. And if the MTU has been reduced, then you cannot send the same message as you sent before. You had to send smaller messages. And the data that you're resending needs to fit somewhere in the reassembly buffer. And so the tile is this minimum piece that with which you pave the whole reassembly buffer. That's why it's fixed.
Thanks, understood from Sergio.
And
but I would like to rephrase what Sergio says. Maybe because here you take a value of 3 for every LoRa product, but if a product is just used in Europe, then you take the US constraint, and maybe here you can have a bigger tiles.
So let's hear what Olivier will say, and I can answer.
We have Olivier as well.
Yeah, we decided that for simplification, and also in some future we will have device going from US to Europe and China and so on, which will move around the globe. So it's already difficult to have something changing in countries. We don't want to add more complexity on that. The cost is a bigger bitmap, but most of the time it will be compressed, so it's acceptable cost.
Make sense? Yep.
Yeah, absolutely.
Thank you, Olivier.
So yeah, thank you.
So, do we have any question?
There's one more from Edgar Ramos, but the tile size might be possible to be negotiated at protocol setup.
Which protocol?
Yes, but yeah, I mean, for me, this might be part of the bootstrapping. If there is something we do later, maybe we should change this behavior at that time. For example, yeah.
Julien from Kelling, so we could also define some rule IDs with different tile size. And as we are aiming to have a rule IDs in F ports, it doesn't cost anything.
I mean, we come back to the argument that maybe the implementation will be a little bit more complex, but yeah, maybe it's still something worth considering.
Dominique, yeah, you could either have multiple rules in the same rule set with different tile sizes, but then you have the size of the rule ID that increases. Or you could, as part of the provisioning protocol, you could provision rules that have different tile sizes.
So the 3 is actually a must, or should? I mean, how is it expressed right now?
It's a must, I think.
Yeah, I think it's a must.
Well, then if you want one day to negotiate it, you'll do another RFC and you will say, oh, now it's negotiable and blah, blah, blah. But for now, all implementations will have to do 3 and that will be it.
So, yeah.
If that's really what you want, that's what you get.
Okay. Well, we might consider whether it makes sense to make it a shoot or something, but it's okay. Yeah.
Or you can have some sentences that it might be overridden by some configuration. It's just a sentence like this and some out-of-band methods.
Okay. Yeah. Okay, thank you.
Thank you, Olivier.
Yes, and water. Okay, so I have very few slides to present 2 things. The first one is data model, I think. It's the first. Oh, Quap, up to you. Okay, so the data model. So to remind you what we have done in the SHIC draft is that we have a very abstract way to represent the rule. So we never say it's JSON, it's Yang, or we just define it as an array. And now we need to have something more formal for different reasons. First one, Pascal talked before about interoperability. For example, if we want to do interoperability testing between 2 implementations, so it's better to have a common format. We also managed it to have some management. It means that, for example, a device can change some parameter in the SHIC controller, compressor. We talk about the tile size. Maybe it's an opportunity to do this. And extra SAS. So we need something that is standard. Another example is Christian that say that maybe we can do a hash of the rule to be sure, for security reasons, that we are using the same rule. And of course, if we do a hash, we need that the 2 ends have the same representation. So we have to study a way to represent in a compact way, because we are in compact device, in an easy way, this information. That's why we are going to investigate a Yang model to see if it fits all the requirements we need for this management. So we have already a draft that will expire soon that present the first Yang model. Last year, IETF, I presented also something that was more evolved on this Yang model, but we are reaching our limits in Yang. So that's why we ask the AD and the chair to see if we can have contact with the Yang doctor to see if we are starting well and we don't make some big mistakes that will appear in the future.
Yeah, so Krishnan, so you saw my request to the management AD a couple of weeks ago for a Yang doctor slot. I really hoped like you would have had a Yang doctor assigned to us by now, but unfortunately it didn't happen. So I'll just keep poking at it to get something done. And So if nothing happens, I'll probably talk to the secretary of the young doctors, which is Mehmet. So I'll probably try to see if I can get a response from the young doctors directly.
Okay, thank you. So this is one point. So we will issue soon a new version of our young model, and this one can be the base for discussion. The other point that comes from during the last call with the core working group. So we had a proposal from Carsten that says that we, for example, we have co-op option, and for the moment we define in LP1 a name for each co-op options. So for the moment it's okay because it's something that is internal to an application, but when we will go to that young model, of course we don't want to make twice the work, and core is defining some co-op option, and then LP1 will have to redefine another space for this co-op option. So one proposal, but we have to discuss it, is, for example, to reserve in the seed space that represent all the value we are manipulating in SHIC, so some space for the co-op option. And for example, here when we will have URI path, it's value 11, so it will be the 11th place in this space, and etc., etc. So when core will create new co-op option, then automatically it will be present here, and we don't have to do any translation. Currently, the drawback of this is that we have to take 65,000 places just for the seed space, which can be a lot. So I don't know if it's reasonable or not to do that, because the seed space can be very, very huge. So it's a possibility. So do we have to do it for co-op option? Do we have to do it for other value that we will find on protocol we compress? So currently that's an open question, and I would like to have your opinion on it.
Laurent, you don't need to reserve the 65,000. You can pick 16,000 or even less, and then you will have a continuation code, and you will pick a different range later. So it's not obliged to take the 65,000 right now. So you can take this approach with,
Petro, right now I think you can have up to 1,000 seats in one block, but if you decide to go this way, maybe we can change this, or we can see what we can do about this.
Just invent a continuation code. Like if your seed almost 1,000, it means go somewhere else. Well, it's
that's perfectly possible.
Just you'll have more ranges with different ranges of co-op. Tons of ways of doing it without booking the 65,000. I'm sure you won't find one.
Let's move. That's the last slide, or? Yeah, that's finished. Oh.
So the next presenter will be Mr. Laurent Toutain.
What? I have not finished. I can leave to Anna if you prefer. Okay, so this is a result of, we had a working group last call on the co-op compression. It was also sent to the core working group to have their feedback. So here is a result of this call. So we move from, now we are in version 9 of the protocol. So we have comments from both groups about what we are doing on this document, so thank you for all the reviewer. We have also a comment from Christian that we talked this week, so it's not here. It's about to make a hash of the rules, the context in both sides when you are doing OSCORE, and include this hash in the AED when you are doing the encryption. So this way you are sure that both devices, or the device and the SHIC core, are using the same rules for the compression. So it's avoid to have confusion if, for example, you code a get into and it's understood as a delete, and of course you will have some bad behavior. So that's something we have also to include. So from my point of view, it's quite difficult right now to push it because we need this data model before doing it, because of course if both sides use a JSON definition and you have one space in one JSON definition and no space in the other one, so the hash will be different and it will be difficult to manage. So it's something interesting, but how to integrate it right now, I don't see really how to do it. You want? No? Okay. So in V8 we have only some text edition, so nothing new. And in V9 we introduced also a command from the core working group. It was about ossification and the risk to say, okay, I am compressing this way, and then the CoAP protocol will not evolve anymore because we have defined its version 1, or we have a rule that say we have this and this and this, and if something new appears in core working group, then it will maybe block by the fact that SHIC cannot evolve. So this is something that is not really a problem from the SHIC point of view, because SHIC is very generic, and when the device evolves, then the rules will evolve. And when everything is designed as a field, we have a way to compress it, to manipulate it, so it's not really a problem, but we had some text to say that there is no risk of ossification with SHIC. Okay, so here is what I said before with Carsten's remark, is what puts the CoAP space into SHIC, so this way you don't have trouble. And I cover this point with the data model. And so we have finished with working group call. All the ticket has been closed and we answer all the questions. So now I turn to the chair. What's the next step?
Well, the next step is to find a shepherd.
Yeah.
So probably Alex, but otherwise we might, I mean, if somebody is interested in trying the exercise of being the shepherd of this document, we can help that person through the process too. So it's an interesting learning curve, so always open. The shepherd is not named right now, so, but if, I'm happy to take volunteers if anybody wants to try the game. Okay. You want to try to be a shepherd? I will help you through. It's not.
Hello, I'm here. I have been shepherding one document for COSI already, so I have some idea about this.
Okay.
I might have a little bit more load on COSI, but I will see, and if I have the time for this, I mean, I will send you an
Come
email
back to Alex and me.
Yeah, exactly.
Okay.
So, Christian, I can pick somebody like you, so I'll just like look for somebody and like probably even outside the group to just do it, just to get.
Please, I mean, because it's open. I mean, I like to have new eyes, basically.
Exactly.
That gives us an additional.
Right? Like, I wanted to make sure that we also get like.
That gives us an additional review and additional scrutiny. It's always good.
Quick comment from Alexander Pilov. Perfect. Thanks to that.
Hello again. This is an update on the OM draft. So the purpose of this draft is to discuss the OM methods and protocols for IoT in the context of SHIC. So we want to start with really simple stuff, things that people do expect when they have IP connectivity. So they expect ICMP error messages when something goes wrong along the path. They want to be able to ping their destination and maybe run a trace route to troubleshoot initial problems. And so we want to discuss what and define what we want to do in the context of IoT. Does that all make sense? And you know, how do we handle that? And first, to keep it simple, we want to address the methods and messages in RFC 4443 and not the extended stuff. So this is I'll come to a question shortly. This is a kind of scenarios we considered, so this is already a year old. Oops, wrong button. Obviously from the internet, if you have IP connectivity, people want to, as I said, get the ICMP v6 error message back. They want to be able to do a trace route. So what do we do? If the error, the problem happens somewhere here on the LP1, what kind of response do we send back? Do we want to propagate those into the LP1 network or not? Is it safe? Is it reasonable, etc.? And also on the other way, probably we want an ICMP v6 error message back from the device if it sends an IPv6 message, but we don't expect the device to run a trace route because you know, there's nobody, there's no keyboard, whatever. So this is probably not something we want to consider. A ping might be something realistic for a device to do. So this draft is first discussing the use cases and then providing solutions. Julien, you wanted to?
You answered my question, Julien from Kerling. Running trace, is it really useful to run trace route in a LP1 architecture because the last hop should be none, or is actually having that implemented on the device? I don't see the use, but you answered that.
Okay.
What we can imagine also is that the trace route stop at the compressor, and you have a specific message that say after that it's a LP1 network. So that could be interesting. That could be a security issue. We have to discuss that.
Yeah, it's really a discussion. By no means do we think we have the definite answer to all these questions. So it's really a debate that needs to take place.
So since Pascal Thubert is an individual contributor, since you've mentioned error, ICMP error, I'm aware, so it's an IPR alert, I'm aware of IPR whereby code in the gateway is not really the context of SHIC or LP1, but similar. It's code in something like the gateway would actually offload the error processing from the device and possibly generate ICMP errors on behalf of the device. And that could be MEC, for instance, any logical function like MEC that would do that. Okay, so there's IPR on this topic.
If Good to know.
Then I know that this IPR can be disclosed to the IETF and we'll have all the run terms, but they just tell you it exists.
Okay.
I'm Bob Moskowitz. I'm looking at your slide there. I'm wondering if you intended it as some typo on the top pairing. You have IPv6 on the top and ICMPv6 underneath. Is there some specific intimation of why the directions are named differently, or is that accidental?
Yeah, what we mean to describe here is scenario. So we're saying we think it would be interesting for a device when they send an IPv6 message out and there's some issue with this IPv6 message in the network that they are able to receive the ICMPv6 error message back. And conversely on the other side. But definitely we have IPv6 flowing both ways and ICMPv6 flowing both ways. But this is a scenario on the device side and scenario.
Very unclear the intent of the picture.
Okay, that's why the talk comes with it. Thank you for the comment anyway. So we haven't worked at all on this since last meeting, except for this hackathon where Laura implemented this part. So we got the code into the SHIC core on this side, and when we set a ping from the internet, then the SHIC core, instead of forwarding the ping and compressing it and forwarding to the device, will respond with an echo reply on behalf of the device. And the way we did it, which is interesting, is kind of reuse the compressor implementation, which has a matching part. We look at rules and we have a matching pattern, and then we apply it for compression, and then we added a few hooks such that when this matching part matches, then we call a special code that sends a echo reply back. So just a point of reference, we have some of this working.
Right, Sandra Cespedes. So regarding that use case, is it going to be something to make sure that the end device is actually alive before replying with a ping back to the, because otherwise you're not making sure that the IP should respond with a ping, right?
Right, that's a very valid question. It's all part of the discussion that needs to take place, and I need to revive this discussion, is what do we want to do? What do we expect? Certainly not responding to the ping at all is probably a bad idea in general, because people expect that, you know, they have an IPv6 device, they have some host with an IPv6 address, they expect to get some answer back to the ping. But what kind of answer do we want to send? How long has the device been, how far back has the device been seen for us to decide that we want to send a reply? I don't know, could be an hour, could be a day, very much depends on the network, on the class of device, if it's class A, class C. Of course, if it's LoRaWAN class C, you expect an immediate answer back. If it's class A, you understand that it may be sleeping, you know, for hours in a row. So it's all part of the discussion. We're on the opening questions at this point.
Yes, for the moment, we answer, for example, if you see a traffic in the last 5 minutes, then you answer to the ping. And if you don't see any traffic, so you don't answer. And so this way, with a management tool, you can see if your device is active or not.
Yeah, it's emulating the liveliness of the device, and you know, LoRaWAN picked 5 minutes just for running the test. But okay, so next steps unchanged from last time. Discuss the use cases on the mailing list. So I will revive this discussion definitely. Is there some other useful OEM stuff that we want to do in the context of IoT and LP1s? And then implement and play with this stuff. Okay. No more questions? Oops.
Okay, hello everyone. My name is Carlos Gomez, and I'm going to present an update of the draft entitled RTO Considerations in LP1. So, first of all, a reminder on the motivation for this document. We have that in many LP1 scenarios, we have long or very long RTTs. In ideal scenarios, we may have RTTs already in the order of seconds or tens of seconds. And due to a number of phenomena, we may also have higher order RTTs with values up to several minutes or even more. So as a consequence, the RTT in LP1 and also the variance of the RTT is much greater than the typical one on the internet. For comparison, the default RTO in TCP is currently 1 second, and the default RTO in CoAP is randomly chosen between 2 and 3 seconds. So we have these particular RTT characteristics in LP1s. However, we also have retransmission timers. For example, when we use CoAP in LP1 and we send a CON message, there will be a retransmission timer running. And also, SHIC defines two modes, always and ACON error, that use retransmission timers as well. So the question here is, okay, how do we deal with these particular characteristics of RTTs in LP1? So the status of the document is as follows. The initial version of the draft was presented in Prague. It contained an analysis of what we now call the uplink RTT. This is a round trip where the first message is in the uplink, the response comes in the downlink, and also it contained a proposal for an algorithm for the RTO. And in this update, we have added this terminology of uplink RTT or downlink RTT. By the way, the latter is the opposite, so the first packet is in the downlink in that case. And also we've added a downlink RTT analysis. Also in this presentation, I'll show an example of some preliminary evaluation results of the proposed RTO algorithm obtained by simulation. So regarding the downlink RTT analysis, we can identify that it comprises two components. The first one is the wait time until the next uplink transmission. And this is because in technologies such as Sigfox or LoRaWAN class A, a downlink packet can only be sent in a dedicated time window that has been offered as a result of a previous uplink transmission. Therefore, this component, this wait time, will depend on the application, and it might take values such as in the order of seconds, minutes, hours. Although it's true that there are also some special cases where if we know in advance that we want to perform, when do we want to perform a downlink transmission, it would be possible also to program beforehand some uplink transmission so that it might be possible to minimize this component, ideally even down to zero. And then the second component in the downlink RTT would be the time since the uplink has been completed until the whole downlink RTT has been completed. And we call this second component a basic downlink RTT. Juan Carlos.
Juan Carlos Zúñiga. In the LoRaWAN numbers, which class of devices are you using? Is it ABC?
I understand, well, this is class A.
Class A? So
yeah.
You have to send the uplink before.
Yeah, so these numbers are only for the second component.
Okay.
Yes. Yeah, so this is after the uplink has been done. Yeah. So we have added a theoretical analysis similar to the one that already existed in the document. That was for the uplink RTT. Now we have added these numbers which correspond to basic downlink RTT for LoRaWAN class A and also for Sigfox for a variety of data rates and uplink bit rates respectively. And the conclusion is similar to the one that we identified for the uplink RTT values, which is that in many cases we have RTOs which are already greater than the default CoAP RTO. Then in the document, there's also discussion of approaches for the RTO. So perhaps in some cases, delay might not be relevant for the application. So in that case, what one can do is just set the RTO to the highest expected RTT in order to avoid spurious retries, and that's it. However, if delay is actually relevant for the application, meaning that it makes a difference to retry after 1 second compared to retrying after 100 seconds, and also if we expect to find higher order RTTs in our scenario, then we might consider using an algorithm such as the one that's presented here. We call it dual RTO algorithm, and it is basically a two-state machine where there's two separate RTO algorithms used. There is the high RTO state, which uses one RTO algorithm which is initialized to values that are compatible with high RTTs. Then there's a low RTO state, which uses a separate RTO algorithm, which is consistent with low RTT values. So for example, if we are in the high RTO state, and then we obtain a number of consecutive low RTT samples, then the mechanism switches to using the low RTO algorithm and vice versa in the other case. So this is just an example to illustrate what we could get where we compare what happens if we are using a standard single TCP RTO, which corresponds to the curve in red. Here in this figure, we show the RTO values produced by this standard TCP RTO compared with the ones that will be produced by the dual RTO algorithm, which are the ones in green, when there's, as an input, the sequence of RTT values that are shown in blue in the figure. As you can see, this sequence in this example is basically that RTTs are by default low, like around 1 second, and then there are a couple of intervals in which the RTTs are around 100 seconds. And we can observe that the TCP RTO, so if we use a single RTO here, it struggles with the variance of the RTT. That's the result of the change of the RTT state. And the TCP RTO produces very large values, even up to 300 seconds. You can see also that it takes some time to converge for the single TCP RTO. And also, the worst case is when the RTT is already 1 second, and meanwhile, during this convergence phase, after a transition of the RTT values, the TCP RTO is still with values of 300, 200, 100 seconds. In contrast with the dual RTO, as soon as there's the detection of a change of the RTT state, it switches to the appropriate RTO algorithm. By the way, in this simulation, what we use is 2 separate TCP RTOs. However, one is initialized to values compatible with high RTTs. The other one is suitable for low RTTs. And as you can see, the dual RTO is able to follow the RTT much closer than the TCP RTO. So one consideration here is that it is actually possible, or that's the assumption, to know a priori in advance which will be the high RTT values. For example, if the high RTT intervals are due to packets being buffered in a gateway that then can only be sent because of some uplink transmission that allows that downlink transmission, then it means that the RTT is actually related. It depends with the time between uplink messages. Also, another observation is that the amount of improvement that can be achieved will depend on the actual statistics, for example, the duration of the high or low RTT intervals. So, well, this was just an example. And, well, there are some questions for the group. And one is, okay, is there interest in this work? And then if yes, then there's a related question, which is, okay, this document contains somewhat hybrid content, like informational content about settings for the RTO, but also an experimental kind of algorithm for the RTO, and also connected with transport area stuff. So, well, what do you think?
Pascal, you are here. So my feeling is that we have a cross-layer issue. That's the main thing, which is like, basically, you get this timeout, whatever it is, at the upper layer, which says, hey, probably my message was not received. And as it goes, there might be an upper layer acknowledgement sitting on the gateway, but your problem is to pull it, right? And there is chicken and egg between timing out on the device and getting this message. Because if you time out, you send a message that will pull it, but then you will also give information to the other side that something was lost, which is not the case. So, because it's just waiting for you on the gateway. So we are missing this interface between the upper layer, whether it's transport or application, above co-op, whereby the transport or application, when it times out, instead of creating a real application event end-to-end, etc., to do a retry or whatever, first, that's something which has a result of pulling stuff. And then if that doesn't work, then the real timeout can happen. But I think we need to describe that model because it's pretty new to the model where you need a message, a layer 2 message that doesn't go further than the gateway to just empty the queue. So that's the first thing. We need to document that. Now the second thing I have is, no, I don't believe that you can, without any cross-layer interaction like that you can tell what the bounded value is for the long RTO, because the queuing theory will tell you that if you get more message from the network into the gateway queue, you get them faster than you pull them, then that queue can become infinite, right, in theory. So if that queue is infinite and it's being emptied at the speed at which you pull it, then you cannot, the RTO can go infinite as well. So we must have some methods to control the size of the queue on the gateway and pull it. So the bigger scheme in which this thing works has to be described.
Yeah, thank you.
Donc, until now, we have taken the device as a device that we know. But I think in LP1 networks, the device is kind of different. Not only have a different RTT, it sends differently, it's asymmetric, timers are different, so the response is different. Until now, we have not studied all the parameters that this device will react slowly, I will say, compared to what we know. So I don't know, this is one first step, I will say, of all these parameters that may change with this new asymmetric, slow, or low power landline. So I think it's interesting. And perhaps not only the RTT, we have many things to study. I don't know if we want to make one document for each one, or we can make the cross-layer study of all these parameters that need some new configuration compared to these LP1 networks.
Yeah, thank you. I understand that next step would be trying to identify like which is the set of parameters. Perhaps not only RTT, as you say. To my mind comes, for example, inactivity timers may also have some dependencies, some relationship with this content. And yes, from there we might be able to see if it makes sense to consider a set of parameters, performance parameters or behavior parameters in the same document, or perhaps if there's some different nature, like study them separately. Yeah.
Also, the asymmetric part is important.
Yes.
Yes. So, Chair Hatton, I would really welcome a problem statement document which explains what are the implications of this pool model on the upper layers, like TCP or whatever application over CoAP. Once we understand what the problems are, then we can look at solutions like this, right? But we need a greater context. Mm-hmm. So the first thing is probably to write this problem statement. And yes, I would welcome that.
Peter van der Stok, did you consider Markov modeling for this problem?
Not yet, but
it might be very appropriate.
Yeah.
Now, to support this work, I think it's very important because with SHIC we are hiding the fact that we are behind the LP1 network, so we have to adapt the server and other components. So it's very important to have such thing.
Thank you.
Thank you, Carles. Do we have any more discussion on this topic? I mean, it's probably one of our more critical topics to discuss with in the future. So, nothing? Okay, so the last topic, probably, Suresh, is the rechartering games. So I did not pull, again, the slides. We've presented them a number of times. We just need to point on IETF 101 instead of IETF 105 on the data tracker. So basically, the bottom line is we have split the first item of the agenda into what is complete, which is the main SHIC document, what is well on the way, which is the SHIC over foo document, which should adapt the SHIC profiles for the particular technologies, and then the SHIC profile itself, which will be the young model that we have now. And so that basically the three main items. And we have added a new item in the proposed charter for what has become the ICMP OAM draft, right? So this is pretty much what we are asking. So Suresh, how do you see the next phase with, it looks, we have documents for those charter items. We are in very good shape already.
So you already discussed the charter on the mailing list, if I remember correctly, right?
Several times we've presented it at IETF 101.
So if it's not changed, just like put the charter in and send it to me. I'll put it and start the rechartering process in the IESG. I just want to wait till the SHIC document is done with the IESG. So that's like, I think the 22nd or something, and then ship out the text to me. I'll put in a new version of the charter, and there's like a bunch of the steps to go through. So I need to do like an informal review, an internal review, and an external review. So it's, each of them is about like 2 weeks long. So it's about like 6 weeks from then.
We've been working for 1 year plus on the charter items anyway. It's just that so the discussion of today about this RTO and cross-layer issues due to the pool model, you have to send a message to get a message back. The more and more we talk about it, the more and more it seems like it's an important topic for us. So should we modify the charter as you've seen it since last year, or to have a topic like this prime statement to start with? I think
that's fine. Like,
that's fine.
Like, so you have like 3 weeks now, right? Like till I can put it on. So like, say like, is the working group interested in doing it? And then if you have consensus, just add it in.
Okay. So we'll go through the mailing list, ask if we have interest in this prime statement. And I guess the RTO discussion will come naturally out of that work, and then we'll charter for it if people are ready for it.
Sounds good.
Okay.
And that will also lead to the deliverables, right? So add a milestone for it and so on. If it's,
soon as you approve the charter.
that's what I'm saying. So add it to the areas we work on, but also add a deliverable. So if it's just a problem statement or you want to work on solution and so on, right? So that's kind of like make them deliverables, because like a lot of the times people are saying, okay, what do you want to deliver as well, right? So I think keep those two separate, because like one of them we can change easier than the other. So make sure it's in the charter and that. And we can work on the deliverables.
So question to the room right now, right? Do we put the prime statements, an obvious one? Do we already put the RTO in the new charter? Is it something? I would like to get the pulse of the room. Are we ready to work on the RTO already? Does it make sense for everybody? Please, if you think we should include the RTO discussion Carlos presented in the next charter, please hum. I repeat because the hum was light. If you think, please listen, wake up.
You cannot like change the result.
No, I just want to make sure, because I see people not doing their mail because nobody does that. So please listen. If you care about the RTO work in this working group, so we already include it in the charter, please hum. If you don't think this group should work on RTO primes, please hum. But the train doesn't want to work on it.
Okay, so just confirm on the list and you're good to go.
Okay, good.
This is Anna again. How about working about lightweight MTM over SHIC?
I missed your question, Anna.
How about make lightweight M2M over SHIC?
M2M over SHIC or SHIC over?
Lightweight M2M.
Compression, lightweight M2M. Okay. Mailing list. We have 3 weeks. So we've proven quite efficient on the technologies we have. So we are doing this DLMS thing already. Some people are working on it. So why not? If there is document, I would like to see the document, right? Maybe start with the document, show us that there is something to do, and well, you need to publish like in the coming weeks now.
Julien from Killing, I would support such work, lightweight MTM.
Okay, so we'll pull the mailing list on this. It would be great to have a document which shows, what kind of delta. I have just no clue what's missing in SHIC as it stands today to do lightweight M2M, if there are new methods or if it's more like the co-op one. So please publish something so at least we understand what the problem is.
Christian Amses, from my understanding of lightweight M2M over co-op, this may not be much more than defining a few more SHIC compression options, and then describing that it can be done with the existing technology. But of course, it needs to be explored.
Okay. So it's pretty much like co-op then, the same degree of work.
Please start the doc yesterday. Is that the full charter, or there is the next items in the charter? Daniel, because, well, my question is, do we have any way to provide the standard, I'm not saying rules, but
yes. So if you care, let's go through those slides again. So basically, that was the old charter, okay? And so the old charter had a very big item 1. Sorry, item 2, which we actually split, as you can see. Okay, and then I will go through charter 2, through the rework charter.
Okay, so it's in it.
So the charter 2, yes, exactly. So we split those things into, so the chic is what we are done. So your question is the item 2, I guess. It's the data model, right?
Okay.
And so item 3 is all the technology-specific documents. And the only new item, really, from the old charter was this OAM work that Dominique has presented. Right, so all those things we've been discussing today, so the young model is item 2 in the new charter. And now we will add an item which would discuss the primes due to the pool model. And as deliverables, we would have a prime statement and a work on RTO. That would be the new thing. And then probably yet another deliverable to be added to actually item 3. So item 3 is chic. Well, is it item 3 or item 1? About, lightweight M2M over compression. Just like
I'm looking at is an easy way to use chic. Make it very easily to be used. That was only my point.
Write a library and everybody can include it. Okay, so yes, the profile is exactly for that. We'll need documents in the profile game. We'll need a document which kind of expresses how we expect to push the profile, the new format on both sides, and probably there will be a need for a provisioning flow which explains how that happens. And if we actually sign the rules, then we'll have to explain how we make it so that the rules that are the same on both sides, so the signature works. So all this should be in a document somewhere. Okay, and we had a last item for today, which was a presentation of 802.15.4 by Charlie and Bob. But as it goes, Charlie is not there. He did not register to meet ECHO. So I guess we'll rethink on what's going on at 802.15.4 at the next IETF, which means that we're pretty much done, and you can basically be the first in the queue for food, which is a good news. So unless there is any question, we will adjourn right now. Okay, so enjoy food, enjoy Montreal if you're not leaving right now, and see you in Singapore. Don't eat chewing gum. Serious. So everybody sign the blue sheets before you go. Blue sheet signed, blue sheet signed. Okay, I'm going to take the blue sheets to the IETF.
Est-ce que tu as vu ta gas factory et ton 007?
Non.
Tu l'as pas? Non. Tu l'as pas? Bon, bah, regarde.
J'ai vu les petites fumées.
Bah, ça, c'est le
Ça, c'est la gas factory, d'accord. Ça, j'ai vu. Et le 007. Non.
J'ai pensé que tu allais dire.
La petite fumée, je l'ai repérée. La petite fumée, je l'ai repérée.
J'ai pas dire quelque chose, il a rien.
Ah, oui, le pistolet, je l'ai vu, mais il n'y avait pas marqué 007.
Non, c'est pas marqué. C'est un homme, je peux pas dire ça.
C'est très joli.